Sweet, bitter, sour, delicious. No, we're not talking about someone, but rather something made sweet with a bitter end. Wine, an enigmatic elixir that whispers the poetry of sun-soaked vineyards and age-old secrets, is an alcoholic drink made from fermented fruits which include grapes, pineapples, watermelons, strawberries, and any fruits you can think of. As you enjoy the sips of your time with wine, have you ever wondered how do people make wine? How does it make you feel drunk when most of its ingredients are just pressed fruits and lots of sugar? Is it really necessary to wait that long for a drink? Let's find out. Winemaking begins by collecting the necessary equipment, which consists of a container, sugar, yeast, a crusher or a blender, an airlock, and the main ingredient, that is the fruit of your choice. Once you have all the materials, you now continue by crushing or blending the fruits until it has the consistency of a liquid, followed by adding sugar into the mixture. Make sure to put plenty of it in. If adding a lot of sugar is a must, that is not the case for your yeast. You don't want your wine to be spoiled now. Then mix. Afterwards, place it in a container with an airlock for fermentation. Fermentation in winemaking is crucial as it transforms the sugar into alcohol, defining a wine's alcoholic strength. It also shapes a wine's character by extracting tannins, developing flavors, and expressing the unique characteristics of the grapes and their origin. Ultimately, creating the diverse array of aromas and tastes found in different wines. Finally, the culmination of patience.
Energy is needed for daily tasks. Similar to how an automobile needs fuel to run, humans, like all other living things, need fuel to act. Our bodies break down food molecules and extract their energy to power all of this physical labor. Cellular respiration is a mechanism that we depend on to function properly in order to provide us with the energy we need to work hard or simply unwind. Plants, animals, and all other living things obtain energy through the breakdown of molecules that are high in energy during cellular respiration. In this instance, we humans consume food, break down the food, and then transfer the nutrients to its bodily cells. The primary energy unit of the cell, ATP molecules, is where store the energy that is released during cellular respiration events. The organism can then employ this abundant, easily accessible stored energy in ATP as needed to power its operations. We organisms breathe in oxygen to support cellular respiration, and we exhale carbon dioxide to release it. These reactions also result in this release of water. Here are three fundamental processes make up cellular respiration: the electron transport chain, the Krebs cycle, and the glycolysis. Food molecules like glucose are progressively broken down during these activities, and the energy from this breakdown is used to create ATP. And one last thing, did you know that cellular respiration and photosynthesis are both quite similar? But in reverse, it should be noted that although oxygen and sugar are inputs in cellular respiration, they are products of the process in photosynthesis. Water and carbon dioxide are inputs in photosynthesis, but they are products of their action in cellular respiration. While the light powers the reactions in photosynthesis, the energy generated during cellular respiration is stored in ATP bonds.
Have you ever wondered how heat works or how different energies are transferred? Well, that's how thermodynamics work. Thermodynamics are a set of scientific laws which define a group of physical quantities such as temperature, energy, and entropy, which characterizes thermodynamic systems in a thermodynamic equilibrium. There are three laws of thermodynamics. First law of thermodynamics states that energy cannot be created nor destroyed. Second law of thermodynamics says that for a spontaneous process, the entropy of an isolated system increases. Third law of thermodynamics says that The entropy of a system approaches a constant as temperature approaches absolute zero. But wait, there's one more. The zeroth law of thermodynamics, which states that two systems in equilibrium with a third system are in thermal equilibrium with each other. This zeroth law was added to allow a consistent definition of temperature. That's all you need to know about thermodynamics, and I'll see you around.